It's 5 minutes past 2, so I guess it's high time to start our first accordion webinar. Thank you to all the attendees. It's the first edition of an event that we really wanted to set up, that has been considered in its possibility of spreading what is the vision of our project, the Accordion project. And the idea of this set of webinars is actually to both communicate and disseminate the achievements of our project, but also to create a venue in which topics that are somehow related to our project, but not necessarily limited to the achievement of our consortium, can be discussed. So we start today with this presentation that is an overview on the project vision and its 3 use cases. But in the forthcoming month, we will have many other presentations that will focus on different aspects of cloud edge related stuff, even in a broad, very broad perspective. But today, we wanted just to start with presenting ourselves. Ourselves meaning our project, our vision, and why we believe in this project and in the achievement that such project is bringing on. As such, I'm in my role of project coordinator giving a general overview on the project, and then 3 responsible for the 3 use cases, namely Michael Dodis, Zbigniew, Ledwon, and Thomas Loven will give for their own use cases and the companies that are providing these use cases to our project. So let's start from the beginning. It's the only way to start in a reasonable way. And let's start not with our project, but even before, with a more general concept, that is the concept of the cloud and why such concept has been so revolutionary. Cloud computing can be seen as a real modern revolution, a modern revolution that achieved what has been even older concept, that has been the utility computing. Utility computing has been a long-lasting dream of an entire research community, namely the ability of providing computing capacity in the same way you can access to all the other kinds of utilities, including gas, including water, heating, and so on and so forth. So our goal is contextualized in this more broad area, the area of cloud computing. However, even beyond its revolutionary extent, cloud hasn't been able to bring with it all the possible application and all the application that can be considered of interest. In fact, there are a number of applications that have been left behind by and didn't take their own part to this revolution. This class of application, typically mentioned and named next generation application, are those which low latency requirements, typically quite hard requirement in terms of latency, bandwidth, constraints on data. So the fact that, for instance, they rely on data that cannot be moved from the place in which they are generated, but also other possibilities encompass the specialized hardware that can simply not be moved to a cloud and is not suitable to be hosted on a big data center like the ones that host the clouds. These are all these set of motivation that prevented some application to be moved on a cloud. But what it came as an opportunity for bringing this vision of utility computing for this kind of application as being the edge computing, namely the ability of not relying on a single remote location in which to host the data and computing capacity, but having something that is really more pervasive, distributed, and decentralized in order to be close to the end users by enabling such low latency, high throughput, high bandwidth, and able to satisfy those constraints on data that otherwise may have prevented the embracement of utility computing from the viewpoint of such kind of applications. Edge computing has then this pervasive nature because it's located in a wide set of different locations. And by design, it embraces heterogeneity because you cannot assume that all these devices are of the same kind. And so by design, edge computing solutions, tools, and technologies has to deal with these heterogeneities and take the best from this. So not take this as a limit, but instead as an opportunity. In doing this and in being composed by this complex kind of resources and application located on a wide area network setup, this as a further opportunity, the fact of limiting the lock-in of users and application to specific providers. But the advantages and the opportunity of the edge computing are not limited to the technological viewpoint, but also has some important impact on an economic viewpoint and perspective. Edge computing is by definition an antibody for big trust due to its very distributed nature. And by being able to exploit and put in the game this distributed set of resources owned by different entities could be a very good opportunity enabling the rollout of European SMEs that otherwise risk to fail in their competition against the big American companies or even Chinese ones. Okay, this then has demonstrated to be a very nice opportunity for providing solution both from a technological perspective and economic perspective for those applications that otherwise were put outside of the revolution brought by the cloud. Accordion has the ambition of doing its own part in this revolution by being able to provide a network and a compute continuum that is adaptive depending on the specific needs of application users, and relying on a heterogeneous sparse set of resources, and then in this way to support these next generation applications that otherwise cannot be executed. In order to do this, Accordion has a consortium of 13 partners scattered around a relevant part of the Europe. And from the viewpoint of its contribution, it's organized on 3 main layers and supported by another activity that is more transversal, that is the techno-economical analysis supporting the definition of the economic viability of the approach. So these 3 layers, as we will see in a while, are basically structured in 3 layers, each focused on different aspects. Starting from the bottom, we have a framework that is dealing with the ability of putting together the resources for achieving this edge cloud computing continuum. Once we have the way to collect the resources and let them be realizing this continuum, you have to manage such kind of resources and the application that you want to execute on such kind of environment. And last but not least, to have a way to properly program and develop application to make them compliant with this kind of continuum. The first one then is the Edge Infrastructure Pool Framework, which aim is to make cloud-enabled, even a small infrastructure that are located nearby the end users. The approach that is followed is the one built around, that revolves around the concept of the Edge Mini Cloud Virtual Infrastructure Manager, that is a component that enables the exploitation of such kind of resources that are located at the edge. And in order to get the best from those resources, it provides a set of mechanisms and solutions that enables their efficient exploitation, starting from, for instance, by lightweight virtualization. In the context of our project, mostly based on containers and unit kernels. It's based on a smart solution for the management of storage at the edge, the ability of characterizing and also indexing and discovering resources at the edge. Once this pool is built, you have, as we mentioned, the need for managing this pool. And as such, you have to, we provide a framework that is devoted to this actual goal. Basically, it's based on the central components of this framework is an intelligent edge cloud continuum orchestrator. So a component that is able to do the right matchmaking of application with the resources in order to assign to each application or portion of application the best resources possible. This is one key element of this framework, but is not the only one. And other important elements are the solutions that enable resilient execution of application, secure execution of such application on this complex set of resources that calls for advanced solution to this end. And last but not least, to ensure that the operation that you put and execute on top of this infrastructure are privacy preserved. The third layer, starting from the bottom to the top of the stack, is the application management framework that is the one that actually assists application developers in bringing their own application on top of the ACCORDION platform. As such, it's providing a novel solution for designing the application model that targets the complex environment that ACCORDION is building, to ensure that the quality of experience of the end user is satisfied by means of very sophisticated approaches, including monitoring of user, modeling of their behavior, and so on and so forth. DevOps and solutions for the network and application management and deployment, again, on this complex set of resources, federated set of resources. And last but not least, the toolkit for actually achieving this development of applications. As I was mentioning before, the ACCORDION demonstrators are three. You will see in a while all the details of these use cases and their interaction with the ACCORDION viewpoint and infrastructure by means of their main actors. So there will be the ones that will present their respective use cases. The first one will be a use case on the collaborative virtual reality, a second one on the mobile multiplayer games, and the third is on the quality of experience optimization in the content delivery. We, as I told you, we will see in 1 second all these three. But again, this is just our first presentation, the first webinar. We will expect to have many others in the future. And as such, please follow us. These are our coordinates in social media. And if you want to follow us, you are more than welcome. And I forget to put here the website of the project is accordionproject.eu. where you will find a way also to subscribe to our newsletter. So please take this as into consideration. Now, I'm leaving the mic and the stage to the first of our three use cases, the one of from ORama VR. So I'm stopping the sharing of the screen.
All right, thank you. Okay, I hope that all of you can see the slides. It's all okay?
Yes.
Great. So, hi everyone. This is ORama VR section of the webinar. My name is Michael Dodis. So, let's start with the mission statement. What ORama VR is striving to achieve could be summarized as follows. Speed up the task of generating training material for potential medical staff by employing virtual reality simulations. This is the basic idea of what we want to do. For this, we have created a tool called the Magus SDK, a software platform which can ease the process of generating high-quality medical training material. It's a proprietary, shared, virtual collaborative engine providing a custom analytics layer with AI cloud-based assessment, geometric algebra functionality for fast 3D transformations, visual scripting facilities for generating educational curriculums, and rapid prototyping of semantic VR software design patterns. So let's look at a video of Magus in action. Right. Just before, we saw that this user is performing quite the complex operation. Everything that you do in this engine is all tracked. All the errors that the users can or can't make are also tracked in our engine and distinguished and analyzed in our analytics layer. In general, it is really important that medical staff get to experience as much of the actual operation that is simulated as possible. The closer we are to an actual real-life representation of the operation, the better. This is why Magus also allows for soft body manipulation and other physical manipulation technologies. In order to provide an immersive education experience, we have to support this technology, since it's easier to remember lessons given in similar environments. Now, specifically for Accordion, what is important is an out-of-the-box multiplayer collaborative experience with high-quality interpolation and more functionalities to make the whole process faster. All that in mind, how can Accordion help us achieve our goal and maybe even surpass it? Well, by promoting collaborative cloud VR training applications via an HMD agnostic framework for untethered operation, and also by optimizing the networking layer. Let's look at all those in detail. So, main problem with VR applications today is that to achieve high quality realistic images, one needs to provide quite powerful hardware. This is not easily accessible for a typical user. On the table on the right, you can see the minimum specifications for Oculus Rift to just run on a personal computer. And that is from 2014. So these requirements are going to keep on increasing for the time being. But with the recent explosive popularity of mobile HMDs, we already know that they have proven to be more comfortable since they don't require cables. So what we want to do is create an HMD agnostic framework for reducing load on less powerful devices. This will let our users experience rich environments while using less battery without having said powerful hardware. We plan to use WebRTC to stream rendition results to the headset and leverage the low latency of new 5G networks in order to achieve the best possible result. More so, we want to obtain more control over how our multiplayer servers may get instantiated and what load they could possibly sustain. I'm gonna go over this right now. So for multiplayer support in our SDK, we make use of photon networking, which works off of an advanced relay server that reduces dependency on the host connection stability and quality. With Accordion, we can host our own Photon relay server instances and have Accordion scale their resources and numbers depending on the current load and the target load. We can also host a relay server specific code if need be quite easily. All right, this is a basic representation of our vision. In essence, users open up the application on powerful remote hardware, which streams results to their HMD. Accordion then can spawn as many relay servers as needed and then place them on specific clusters depending on where they are needed. An evaluation model will run in the background, which can determine some runtime settings for the users and the relay servers to ensure the best possible experience for everybody. Let's look at the current state of affairs. So, Photon's relay server is ready to be used without making use of Photon Cloud or any servers that they host. So we are going to test that separately. We also started work on the offloading component, so streaming rendition from a remote device to an HMD. And we were relatively successful considering the maturity of these new technologies. Last but not least, we have done some basic tests to find some metrics that could be used for the evaluation phase. And we have a formalized plan of the lifetime and interactions of the main three components of our system. So what's left is to port over our SDK to Linux, since it currently is Windows only, as well as finalize the offloading part and provide the actual integration with the Accordion platform to bring it all together for the evaluation phase. Thank you very much.
Thank you very much, Michael, for your presentation. I suggest to keep all the questions for the end of the session, if possible. So I'd rather prefer to give the mic to Zbigniew, not before to mention that we are about 80 attendees to this meeting, so I think is a very nice result.
Yeah, hello, everybody. Let me share my screen. Okay. So hello again. My name is Zbigniew Ledwon. I'm from Orbital Night. And Orbital Night is one of the use case providers for Accordion project. And we are very happy that we can participate in this project because we think it's very, very interesting and great. So before I walk you through our use case, maybe I'll say a few words about our company. So Orbital Night is a mobile games development studio based in Warsaw, Poland. We released so far a number of games, both for iOS and Android platform. And we are glad to inform that we recently hit the 100 million downloads mark. So this is a huge success for us. Our best known games, starting from the oldest one, is Kikarino World, and we recently released very successful 4 games, which are Castle Wreck, Crazy Kick, and Fort Master, and the last one, Spire Blast, which was released on Apple Arcade. And currently we're working on multiple new projects, and we are also working on a multiplayer game engine, which is also a part of Accordion project. We think we hope we will build some exciting new games, multiplayer games, using this engine. Okay, so as I said before, we are one of the use case providers, and our use case is a multiplayer mobile game. Our goal is to have up to 100 players playing at the same time on one server, and have many such servers deployed across Accordion Federation. And this deployment will depend on geolocation of the players. Such a smart deployment will be possible thanks to using Accordion's AI-based network orchestration, based on the performance metrics and, as I said before, players' geolocation. Yes, this is an overview of our game system, and on this diagram you can see most important components of our game system and how it relates to Accordion platform and Accordion Federation. It is a simplified diagram just to show the communication and cooperation of our system to the Accordion system. So our system consists of game servers. Game servers will be submitted through Accordion management website and deployed on mini clouds on the edge by Accordion Orchestrators. Game client is will be available to download in Google Play Store and will be available for Android devices. Third component of our game system is game server's status database. It will be gathering game servers information such as server geolocation, capacity of servers, current load, and players information. And all this information, all this data will be used by Accordion orchestrators to manage our game servers. Yes, and a bit more about Accordion orchestrators, because they are, from our point of view, from the point of view of our use case, it is a key. These are the key components of our game system. It will they will allow for automatic setup and scaling process. Accordion orchestrators will, based on the information I showed before, will be able to decide where to deploy game servers, if they should be deployed, and sometimes they where and when they should be removed from the resources for the Accordion Federation resources. As I also said before, the place where game servers will be deployed depends on geolocation of players. It is very important because we want to work on network to minimize network latency, and this closeness of servers or game servers to the game players will guarantee that this network latency will be minimal. So this is the quick overview of our use case for Accordion. And last but not least, what we will gain from participating in as a use case provider. What will we gain from participating in the Accordion project? We will gain, of course, a lot of improvements in our system. We will have automated game server deployment, which will allow us for automatic scaling and allow us to handle almost any number of players. And because game servers can run anywhere in Accordion Federation and will be smart selected, the geolocation optimization and latency improvement will be possible. This smart orchestration will also lead to cost optimization, which is what is very, very important for us. And all these improvements will lead to overall a better quality of experience for end users, what is our goal. This is the most important thing for us. And that's all. Thank you very much.
Thank you very much, Zbigniew. Again, let's move on with our presentation, keeping the question for the end. Tom, if you want to take the mic, please.
Okay, I'll share my screen as well.
Yes, we can see it.
Hi, everybody. Can you see my screen?
Yes,
okay.
Yes.
So, hi again. My name is Tom Loven. I'm Plexus project coordinator for Accordion, and I will present use case 3. I will start with a brief overview of our company, then provide some context about the fundamentals of the use case, and finally present the use case. So, Plexus is a Spanish technological company founded 20 years ago. We create products, innovative solutions, and lead transformation projects. We work as a hub of engineering, innovation, and design. Here in the image, we see an overview of our company, which has been awarded as one of the 1,000 most promising European companies. By now, we are over 1,600 employees, and we have 17 offices in Spain, from where we work for clients all over the world. Even though most of us are working remotely at the moment. Most members of our Accordion team are based in Santiago de Compostela, which is in the upper left corner on the map here. So, two of our key products are Trackers and Amblic. Trackers is a geolocalization platform which processes and analyzes the information obtained from mobile devices detected by access points within a Wi-Fi network. This product is implemented in shops of various retail brands and commercial centers, allowing them to learn from customer behavior. Amblic, on the other hand, provides digital signage and works as a content manager where content can be programmed to be reproduced on screens, for example, in a hospital, train station, or mall. Initially, these solutions were independent and information was not exchanged between them. Here we see an image of Trackers. On the left, you can see the data analysis part. The data obtained can be aggregated on different levels. So this facilitates to see movements per zone, per center, but also make comparisons on a regional or on a corporation level, and also make comparisons over time. On the right-hand side, you see the features of the customer analytics part. Customer analytics allows to identify customer profiles and habits. An actual approach is to detect hotspots, and based on this information, customers could be redirected to less crowded areas. It also allows to see metrics on number of returning customers versus new customers, which allows to measure the effect from marketing campaigns. Here we see an image from Amblic and its features. So in Amblic, clients can upload their content, like images, videos, announcements, all kind of media types are supported, and they are uploaded into a multimedia library. From here, content can be scheduled to be broadcasted. For example, a message or a commercial can be programmed to be shown between 10 and 12 o'clock in the morning on the screens within a specific area. Here, in this image, we see, for example, a promotion for a vacation and indications to follow the lights. All this can be adapted. So the transitioning to the Accordion platform will support the Plexus business case to provide targeted content by integrating both products, Truckers and Amblic, to ensure lower latency and higher performance on average network conditions. So this new hybrid cloud edge platform will allow for processing of device information on the edge, reducing latency, and allow for advanced calculations to be performed in the cloud, applying machine learning techniques. As a result, content delivery to different devices and the measurement of their response will be done in a consistent way across different devices and connections. So we'll now present the use case. So to achieve these objectives, our use case consists of two parts. First, we have the client identification and adapted content displayed on screens part. So here, characteristics are obtained from the probe requests, from the mobile devices, from the clients in a certain venue, like a mall, for example. So what do we derive? For example, the time and range or the brand of the device. And then based on this information, a content decision can be made, and content reproduced on the screens within that space is adapted. So these content decisions are made on the edge to reduce latency. For example, in case a specific area is too crowded, a message can be broadcasted indicating this or asking to take precautions. So here in the image, we see a situation where the number of current persons is still below the threshold. On the right, we have the second part of our use case, which is a mobile augmented reality game. This is a kind of customer loyalty game where points can be won based on users playing against each other. A 3D object, as seen in the image, needs to be captured in order to gain points. Depending on the interaction between the user and the 3D object, the game scenario changes, since the location is determined on the edge. The 3D object, here it's based on the logo of Plexus, but it can also be based on the logo of any kind of client or brand. So, as you can imagine, there are many challenges to implement this use case. I'll briefly discuss our three key challenges. The first is to achieve autonomous content decisions based on the information from the probe requests from mobile devices processed within the edge and cloud environment. Another challenge is to channel all data and processing orchestration within the Accordion platform. So to enable a decrease of the latency between the different level nodes and the sensors involved. This aims to increase the communication quality and the speed between the first level nodes and the final nodes. And finally, the optimization of the user experience of the AR game, also called quality of experience. In mobile games and applications based on spatial location, this quality depends largely on speed and latency. So therefore, an edge computing based strategy will try to reduce this processing time. So until here, a first introduction of our use case. Currently, we are working on a first version, and we have already developed the edge component, which is detecting mobile devices and can also make content decisions. And this week, for example, we are testing the integration between the Edge and Amblic. In the following webinars, we hope to go into more depth. I hope you find it interesting, and thank you for your attention.
Thank you very much, Tom, for this. And okay, now if there is any question from the attendees, please. In the meantime, that you decide if to ask question, let me thank all the person that contributed to the organization of this set of webinar. First of all, Ferran from Telefonica that did a lot of work for making this possible. And again, if you have any question, raise your hand using the command in Zoom, because otherwise we cannot see you and see your question. So please, in case you want to ask something, click raise your hand, and someone of the host will give you the opportunity to present your question, actually. Okay. Apparently, we don't have any question. No. Okay. Then it has been anyway very nice to have almost 80 attendees to this event. And please don't hesitate to contact us using the channel we were presenting you before. So the social media channels, the email, the website, for whatever it could be interesting for you. And then thank you very much for attending this meeting. It has been a pleasure for us. Again, from Thierry. Thank you for the presentation. Okay. Okay. I see two new messages. Okay, so basically saying thank you. Thank you, and hope to find you again here in the next event. Next event will be given by Professor Massimo Villari from University of Messina in regarding the osmotic computing, and it's a way to actually properly orchestrate application on data on the cloud edge continuum. And as I mentioned, the idea and the assumption with this webinar is to mix some content that comes from the project with some content that comes from outside the project. Next week will be the case for content outside the project. In the week after, we most likely will have a presentation again on Accordion, possibly on its architecture. But again, stay tuned. We will let you know by email and by the channel we set up. Thank you very much for being here. I guess we can stop here then.